Hey guys, what's going on? It's me, Chavez. It's the summer. It's almost 1 a.m. It's a good time to do a UH quiz. I noticed I didn't have this one in there. IBP stands for, excuse me, integration by parts. And let's get right into it, guys. So this is calculate the integral, and I have this, and you have to, in case you don't remember what I'm talking about when I say integration by parts, u dv equal, that's a v there, equals uv minus integral v du. So that's integration by parts, guys. There's an acronym that's going to help me, LIPIT, logarithmic inverse polynomial exponential trig. So I look at this and I'm like, okay, well then that means I'm going to make this my u, and I'm going to make the 4x with the dx in there my dv. So I'm going to come here, I'm going to go u equals, and if you want, you can move the 6 to the front, or, it doesn't really matter. Ln of x to the 6, since I see ln x to the 6 as, my in there. Like, again, you could have used log properties, but, that's fine. U du, and I'm going to go v dv. So if u is ln of x to the 6, that means my dv is going to be 4x dx. So antiderivative of 4x, add 1, divide by that number. So 4x squared divided by 2, so it's going to be 2x squared. There it is, that's my v. And then my du, I guess I'm going to just take a derivative here. Well, we're taking a derivative because that's what we got to do. 1 over x to the 6 times the derivative of x to the 6, so 6x to the 5th. Yes, you're right. We could have just moved the 6 to the front and we would have gotten 6 over x. See, the 5 of these x's cancel out and you still have an x in the denominator. 6 over x. Whatever you think is easier. All right, guys, so now I'm ready. So I'm going to go put the equal sign here, and I'm going to go uv. So I'm going to write 2x squared ln of x to the 6 minus integral of v du. So integral, v is 2x squared, du is 6 over x. So I'm going to have 12 over, nope, not just 12x. 12x dx, because one of these x's cancel out, and you can see that you're going to have 1x left. So there it is, guys. And now this is pretty easy to do. So let's see, 2x squared ln of x to the 6 minus, and then add 1 to that exponent there and divide by that number. So 6x squared plus c. Would have this one been a good one for a tabular method? I mean, I don't know. You can try it out. I'm pretty sure it would have worked also. But there it is, guys. So let's see, 2x squared minus 6 minus 6, 2x squared ln x to the 6 minus 6x squared plus c. All right, let's go to the next one. This one looks like a good one for tabular method. Lipit. So logarithmic, nope. Inverse, nope. Polynomial, so there it is. So I'm going to write d for derivative, I for integral. Remember, you always start with a positive. So 5x, and the derivative of 5x is 5, and the derivative of 5 is 0. And then antiderivative, so I'm going to write e to the negative 4x. I'm going to be taking antiderivative of that, right? So e to the negative 4x, and then if I was taking the derivative, I would have multiplied it by negative 4, but I'm doing an antiderivative, so I'm going to go divided by negative 4. So there it is, and then I'll do it one more time. So I'm going to have the same thing, e to the negative 4x. I'm going to divide by negative 4 again. Negative times the negative is a positive, so over 16. You can also write 1 over 16 there. Plus, minus, plus, if you're doing tabular. And then you're going to go this way. And really, you're just doing integration by parts over and over again. That's all that is. You're doing uv minus v integral v du over and over. So yeah, so here it is, guys. So let's see. I'm going to start out with a negative. So I'm going to go this equals. So I'm going to put negative, let's see, 5x e to the negative 4x over 4. Why did I write negative first when there's a plus symbol? Because I see a minus there. A negative with a negative 4 there. And then I go to the next one. I have a minus, and then minus, and this is going to be 5e to the negative 4x over 16 plus c. I don't see any issues, and we look for that, and here we go. All right, and so far so good. Let's see, perfect. This is a perfect example to do tabular method. I want to have a linear expression inside your sinusoid, so we're good. So I'm going to write d for derivative and I for integral. I'm going to make my u the 2x. So 2x, 2, and 0. and I'm going to make my inverse, or the integral, sine 5x. So when I integrate sine, I get negative, because remember, it's antiderivative of sine is negative. So negative 1/5 cosine 5x. That's just chain rule, that linear 5x, put the 5 in the bottom there. And then when I take the antiderivative of 1/5 cosine 5x, it's going to be still negative. It's still, because you don't change the sign. And you're going to be multiplying that 5 by 5 again. So 1/25 sine of 5x. And I think that's it, because I don't need any more steps because of that 0 there. So here it is. Plus, minus, plus. So I start with this one. So it's going to start with negative. So negative 2x over 5 cosine 5x. And then I'm going to write minus, but I have a negative here, times a negative is going to be a positive. So plus 2/25 sine 5x plus c. So there it is, and we look for that, and here it is. So far so good, guys. So far so good. All right, I got a polynomial right here with 28x squared. I have a sine x. It is a good one for tabular. Notice that I have limits of integration here. So the definite integral. So I'm going to write the word limit. You don't have to. I mean, you can already see what's going on. D for derivative, I for integrand or integral to integrate. Remember, I always start with a positive here. 28x squared, and then I'm just going to take derivative of 28x squared. Let's see, 30 times 260, so 56. So 56x, and then derivative of 56x is 56. And the 56 is 0. All right, so let's see. So I'm going to write sine x. Thank you for making it nice and simple for us. There'd be nice. Antiderivative of sine x is a negative cosine x. Antiderivative of cosine x is a negative sine x. And that's it. That's all you need. You don't need the 0 one here. Actually, no. You're going to need it, because we go in a diagonal here when we pair the terms up. We pair the product up. Antiderivative of negative sine x is a positive cosine x. Now we're good. We're going to do this. Here's what I was talking about. Now we're good. And plus, minus, plus, and we're good. So let's see. So this guy equals, let's see, I'm going to have a negative 28x squared cosine x. So that's positive times the negative. And then the next one is negative times the negative, so it's going to be a positive, plus 56x sine x. And the next one's going to be another plus. So plus 56 cosine x. And all three of these terms, upper minus lower, from 0 to power over 2. So upper minus lower. So you just got to know a little bit of pre-calc, guys. Side note, cosine of pi over 2 equals 0. And sine of pi over 2 equals 1. And then, of course, cosine of 0 equals 1. And sine of 0 equals 0. That's just from pre-calc, right? The unit circle properties there. So I'm going to do upper minus lower, guys. So upper, when I plug in a pi over 2, this guy goes to 0 because it has a cosine in it. And then this guy, the sine of pi over 2 is 1 times 56 times pi over 2. So 1 times pi over 2 times 56. 2 goes into 56 28 times. So I'm going to write plus 28 pi. Remember, sine of pi over 2 is 1. And then again, cosine of pi over 2 is 0. So plus 0. That's upper. And then I got to do lower. That has an x on it. So 0 times cosine, we're done, right? 0 times anything is 0. And so again, here we get 0. And then here we're going to get that 56. So there we go. And I guess I didn't need a bracket there. So yeah, so there it is. That's my answer. So it looks like it's 28 pi minus 56. So there it is. And I know what you're saying. We're going fast here. And then you're like, we're just speeding through this, and you're thinking, yeah, I can just use tabular method all the time. And I guess technically you kind of can if you are experienced enough and you can see the patterns. And I guess technically I'm not going to tell you that you can't use tabular method on this. But notice that on this one, if you set your u equal to 12e to the x and you keep taking derivatives, it's only going to be 12e to the x. And then notice your dv about cosine x. You're always going to, whenever you do the antiderivative, you're always going to have a cosine sine, cosine sine, cosine sine. So you can go forever with tabular method. So it's probably best if we're rookies to do it, to just do this twice until you get to the same expression, and then just put everything to one side and divide by 2. In case you're wondering, like, Chop, what are you talking about? So I'm gonna go ahead and write lipid here. You know what? I should probably write it in blue, right? Because I have red above. So let me write it in blue, and then a little bit I'll switch it back to red. So lipid logarithm, inverse, polynomial, exponential trig. So exponential trig. So that means u is going to be 12 e to the x. So u du. I'm going to write v dv. So my du is 12 e to the x dx, and then my dv has to be cosine x dx. So my v is going to be sine x dx. Oh, sine x, just sine x. Sorry about that. I don't see any issues. I think we're good. Yeah, we're good. So I'm going to go, this must equal, let's see, uv. So I'm going to write 12 e to the x sine x minus integral of v du. So sine x times 12 e to the x dx. I'm going to write the 12 e to the x first. 12 e to the x sine x, and then put the dx. Now notice I have another 12 e to the x sine x, which is, not really much different from this. But if I were to do integration by parts again, then I'm going to get back to 12 e to the x cosine x, because obviously I got that right there, right? So I'm going to do it one more time, just with what I circled there. So what am I going to make u? I'm going to make u equal 12 e to the x. So du is going to be 12 e to the x dx. And then v and dv, I'm going to make v equal to sine x dx. So my v here is going to be a negative cosine x. Rid of a cosine is negative sine, so that's why I got to put the negative there. So this here in red is going to be uv. So I'm going to have 12 e to the x and then negative cosine x. I'm going to put the negative here, cosine x, minus integral of v du. So when I put v du, so I'm going to put this here first. And notice that I have a negative here, so it's going to turn that to a plus. So plus 12 e to the x cosine x dx. Now remember, that's what all this blue thing here, I still got to distribute that negative. So I have this, and then I have that negative right there is this one. So that negative is that one right there. I got to distribute it. So now here's what you're going to have. I'm going to bring this guy down. So that is integral of 12 e to the x cosine x dx equals, and then what did it equal? Here's my first one. 12 e to the x sine x, and I'm distributing that negative, minus a negative, so plus 12 e to the x cosine x minus integral 12 e to the x cosine x dx. All right, so there it is, guys, plus c, right? Plus c. Well, we'll worry about the plus c in a little bit. So now what I'm going to do is we're just going to do algebra. Now I'm going to move that to the left. So you're going to have 2 of those, because that's a 12 e to the x cosine x, and I have 12 e to the x cosine x there. So I'm going to have 2 of these, 12 e to the x cosine x dx equals 12 e to the x sine x plus 12 e to the x cosine x. And then to get rid of that 2, just multiply by half, right? So times 1/2, whatever you do to one, you do to the other. So times 1/2. So here we go. So we're going to have integral of 12 e to the x cosine x dx, which is what we initially were looking for, is nothing more than 6 e to the x sine x plus 6 e to the x cosine x, and then don't forget your plus c. And there it is. So let's see, what do we got right here? All right, so let's see. This one hopefully will be fast. We'll see right now. Let's see. All right, on this one, what we're going to do is, again, we take our little lipid, and you can already see, let's see, this arc sine, that is your inverse. So it's an inverse trig, I know, but it's still, it's an inverse, so that's going to be your u. And you can make a case of taking that 10 on the outside, but just leave it. So let's see, your u is equal to arc sine of x. And so that means your du is going to be 1 over square root of 1 minus x squared dx. So v and dv. So your dv is 10 dx, so your v is going to be 10x. So antiderivative of this is going to be uv. So let's see, u and then v. So 10x arc sine of x minus integral of v du. So v du, so tan x over square root of 1 minus x squared with a dx on the side. And then when you get to here, you're like, well, what do I do now? So on that, you just do u sub, guys. And you've been doing u sub for a while now, hopefully. So I'm going to set u equal to 1 minus x squared. And how do you know that you did u sub here? Because you can see that if you take the derivative of 1 minus x squared, you have a linear expression. So, and I have a linear expression in the numerator. So negative 2x dx. So I already have a negative 10 there. So let me pull a 5 on the outside, and then I can put a 2 on the inside here. Now remember, I need it to be a negative 2, so I'll put a negative there. If I put a negative on the outside, that turns to a positive. All right, so now this right here just goes to 5 integral of, let's see, 2x dx is du, so 1 over square root of u du. So that's just the same thing as saying this. Let's see. So I'm going to go 5, and then that's u to the negative half. Add 1, so u to the half. Divide by half, so that means times 2. And move this little equal sign. Times 2 plus c. All right, so I got everything I need. So this is tan square root of u plus c. But remember, that was not what the original was. So what's my final answer? So I'm going to drag this down. Tan x arc sine of x. And then I see a plus what? So 10, and what was my u? 1 minus x squared. So tan square root 1 minus x squared plus c. And there it is. Oops. And there it is. All right, let's keep going, guys. Question 7. All right, on this one, you can do integration. Well, yeah, you can. You're going to have to, right? Eventually, that's all. This quiz is integration by parts. But you can't do tabular method because you need to do tabular method, you need a linear expression in there, guys. And I guess you could do a hack. Yeah, let's do a hack first. So let's see, integral, and I'm going to break this down to x times x squared cosine of 5x squared dx. And I don't want to call it a u because we're going to be using the u in a little bit. So I'm going to say w is 5x squared. So then dw is 10x dx. So I don't have a 10x dx. So I'm going to put a 10 and I'm going to put a 1/10. So then there it is, guys. And I can write everything in terms of u again. And if you're wondering, well, Chop, what are you going to replace x squared with? Well, w equals 5x squared, so w over 5 equals x squared. So here we go. So I have a 1/10 on the outside. Integral. The 10x dx is du. The x squared is w over 5. So in a little bit, I'll go ahead and, let's see. What am I going to put so for the x squared? Yeah. So I'm going to write w over 5 cosine, and the 5x squared was just w. See? And then dw. So I think I got everything the way I wanted it to look. Yeah, I think I'm good, guys. I think I'm good. I'm going to go u equals... Let me just make sure. I just want to make sure. Let's see. X squared is w over 5. That's true. And then x, 10x. Yeah, that's fine. You can, if you want, bring that 5 out. It might make life simpler. I'm not... well, yeah, it doesn't matter, guys. It really doesn't. W over 5. There it is. There's my u. W over 5. du equals 1/5 dw. And then let's see. v dv. dv is cosine w dw. So v is going to be equal to sine w. So there it is. I think everything looks good to me. So I have that 1/10 on the outside. And then bracket. And let's see. Let's do antiderivative of this right here, integral of that right there. So uv, so w over 5 cosine w, sine w. Sine w, I don't see any issues, minus integral of v du. Integral, I have a 1/5 on the outside, or I guess you can write the 1/5 on the inside, doesn't really matter there. Integral 1/5 v du, sine w dw. Okay, I think we're good, guys. So let's see. Let's see here. Antiderivative of a sine is negative cosine. Negative times negative is a positive. So I have 1/10 w over 5 sine w plus 1/5 cosine w plus c. All right, now remember what w was. W was 5x squared. So finally, 1/10. And I'm going to write, let's see, what was w? 5x squared. So 5x squared over 5 sine w. We'll cancel it right now. Plus 1/5 cosine. And, well, remember, w was 5x squared, and I didn't replace it, right? So there it is, 5x squared and 5x squared plus c. Distribute the 1/10, and finally, here's the 5's cancel out, and you're going to get 1/10 x squared sine 5x squared plus, and then distribute the 1/10 again, 1/50th cosine of 5x squared plus c. All right, there it is. So let's see, did we get it? Yeah, we got it. Yay. All right, let's see. Again, we're going to have to do another hack, guys. Here we go. With this one here, guys, we can't do tabular method or anything like that just yet because, again, just like before, we need the argument of cosine to be linear. So we need must be a linear expression. So here we go. I'm going to go ahead and, again, just like last time, we're going to do a hack. I'm going to say that w equals ln of x. So dw equals 1 over x dx. Let's see, how's that going to help us? From that, we know that x equals e to the w, because inverse operations, right? E. So let's see, what are we going to do? I'm going to put an x on the bottom. I'm going to put an x on the top. And yeah, we're going to go with it. Here we go. Here we go. By the way, I just balanced it out, right? So if I put an x on the bottom, I got to put an x on the top. You didn't really change the value of it because it's like you multiply by 1. So here we go. I'm going to see the 20x. And remember, we said that x is equal to e to w. So now I have 20 e to the w. And then cosine. And then we said that ln of x was w. So cosine of w. And then 1 over x dx is dw. So dw. All right, we got it, guys. We got it how we want it to look. So now I'm gonna go. Now I guess we could use tabular method. I guess let's try it out. No, let's not, because we can go forever, right? Unless you know where to stop. But we're not there yet. So we're gonna say that u equals 20 e to the w. So du equals 20 e to the w dw. uv and then dv. We're going to say that dv is in cosine w dw. So v is going to be sine w. So here we go. This expression, which was a hack, right? It was from this one. So this expression is uv. So 20 e w sine w minus integral of v du. So again, we're going to have 20 e to the w sine w dw. And then just like before, we're going to do u substitution again with this right here. Okay, so my u is going to be 20 e to the w. So then my du is going to be 20 e to the w dw. And let's see, v dv. My dv is going to be sine w. So antiderivative of sine w is going to be a negative cosine w. So let's see, uv minus integral of v du. All right, so here we go. So from this is uv, so I have, let's see, uv negative 20 e to the w cosine w, because I have a negative right there in the front, minus integral of v du. So negative times a negative is going to be positive 20 e to the w, 20 e to the w cosine w dw. And then look, I have this again as that. So just like before, no, don't forget that negative. So all this, and then I have that minus sign right in front of that. So when you distribute, so let's see. So this expression right here, integral 20 e to the w cosine w dw is nothing more than, let's see, this one here first, 20 e to the w sine w plus, because I had to distribute this, plus 20 e to the w cosine w, and then minus integral 20 e to the w cosine w dw. And then again, just like last time, I'm going to move this to the left. So we're going to have two of them, and I'm going to multiply by half to get it to half, to get the integral by itself. So I'm going to have integral of 20e w cosine w dw equals, then half of 20 is 10. So 10 e to the w sine w plus 10 e to the w cosine w plus c. But it was never w. It was never w. So then we substitute back what we had. So integral 20 e to the w is just x. Let's see, right here. Well, actually, we can just drop it, right? So 20 cosine, so 20, and then that was x, but it canceled with the x in the bottom. So cosine, and then w was ln x, cosine of ln x dx equals 10 e to the, what was w, ln x? So e to the ln x is just x, so that's just going to be 10x sine of ln x plus 10x cosine of ln x plus c. And then that's it. If I didn't make any mistakes, that's what we're going to look for. And sure enough, there it is. All right, we're almost there, guys. All right, this one, it's probably best if we do this one with tabular method, guys. D for derivative, I for integrate, and we're going to start with the 4x squared. The derivative of 4x squared is 8x, the derivative of 8x is 8, and the derivative of 8 is 0. All right, so let's see. I'm going to write e to the negative x. Antiderivative of that is e to the negative x times negative 1, and then e to the negative x times negative 1 times negative 1 again, so positive, and then antiderivative of that is negative e to the negative x. I think we did everything okay. Tabular method, boom, boom, boom. So let's see, antiderivative of this definite integral is, let's see, plus minus plus minus. So negative, because I have a negative here in the front, 4x squared e to the negative x minus 8x e to the negative x. And then let's see, I'm going to have another minus because that's a negative there, minus 8e to the negative x. So plus minus plus 9. I think we're good. All three of these, upper minus lower, from 0 to 6. So upper minus lower. So let's see. Negative 4 times 6 squared, so that's 36. 36 times 4, what's that? 144? So negative 144 e to the negative 6 minus, and then 8 times 6 is 48, so minus 48 e to the negative 6 minus 8 e to the negative 6. Okay, we got that part. We got the upper. Minus the lower. Let's see. 0, 0, and e to the 0 is 1, so minus negative 8. All right, let's see. 144 plus 48, that's 192. And if I add another 8, that's 200. So negative 200 e to the negative 6 plus 8. Alrighty, this one here, guys, we're going to have to do a hack. So we're probably going to take up all this space here. So my hack, or our hack, is we're going to have to split this up into secant squared times secant x, right? So you can put the 10 on the outside if you want, or leave it. It doesn't matter. So I'm going to go 10 secant x, secant squared x dx. So there it is. And then our hack's going to be, it's pretty easy to take a derivative of secant x, and it's pretty easy to take the antiderivative of secant squared x. So there it is. That's our hint. So our u has to equal 10 secant x. So du is equal to 10 secant x, 10x. And then our v and dv, the dv has to be secant squared x dx. And then the v is going to be antiderivative of secant squared is tan x. The derivative of tan x is secant squared. There we go. So uv, so I'm going to write it right here. So here we go, uv. So I know I say so a lot. 10 secant x, tan x. And maybe that's already a hint, right? So 5, nope. Well, okay, you know what? The answer is obviously the 5 there. So let's just keep it going. You'll see right now how it's going to get there. 10 secant x tan x minus integral of v du. So we're going to have tan x and then times, I'll put a 10 here in the front, secant x tan x. Okay, so now this right here, this one right here, I'm going to go ahead and change my colors. So that is going to be integral of tan parenthesis, and I have two of these tan squares. So I'm going to write tan squared x secant x dx. And then this tan squared is what I'm going to replace. Remember that cosine squared plus sine squared equals 1, right? Cosine squared x plus sine squared x equals 1. And the only way to get a tan is sine over cosine. So I'm going to divide everything by cosine squared. Yeah, there's always trig identities, guys. 1 plus tan squared x equals secant squared x. So tan squared x is equal to secant squared x minus 1. So that's what I'm going to replace for that right there. So here we go. I'm going to come back and I'm going to say that is integral 10 there, parenthesis, secant squared x minus 1, close it, and then secant x again. I'm going to distribute. And yeah, we're going to have to know what the antiderivative of secant x is, which we will right now. So yeah, so now we're going to have integral, let's see, 10 like so. We're going to have secant cubed x minus secant x dx. And so now, we're going to go ahead and I'm going to put the 10 on the outside, guys. And we're going to separate this into two integrands. So I'm going to write it as secant cubed x dx minus integral of secant x dx. And we're going to have to do this. So yeah, it's not over. We're going to have to do that by itself. So remember, we still have a bracket here. All right, so doing the secant x, let me go ahead and do it right here. Integral of secant x, I guess I should put it in red. Integral of secant x dx. We're going to multiply that secant, and when you're wondering, like, where did this property even come from? Really, it's just from trial and error, guys, and looking at some textbooks and Googling that you'll figure out that there's all these hacks. So this is just a 1, right? So you didn't do anything. All you did was just multiply by 1 there. And when you distribute that, let's see, you'll have integral of secant squared x plus secant x tan x all over, and this is just secant x over 1, so you still have secant x plus tan x and dx. And then you go u, you make a u substitution here, and we're going to say u equal to secant x plus tan x. I know, this is almost like magic, right? This is kind of like when you pick up more experience or you see like different methods. So, yeah, this is overkill, guys. I'll agree. The derivative of secant x is secant x tan x. So we're gonna write secant x tan x plus the derivative of tan is secant squared x. And that's actually exactly what we have. Secant squared x and secant x tan x. And then if you think about it, there it is with the dx there. So we have integral of 1 over u du. You can say du over u. So this is ln absolute value of u plus c. So we've taken care of that one. And now we got to take care of this one. But we already know that we have this expression to begin with. So let's go ahead and distribute this 10 now. So here's what we have. So we have the initial. So let me go ahead and write it in green. Integral tan secant cubed x dx equals, and then what did we get the first time around, or the first iteration? We got this guy here. So equals 10 secant x tan x. So you can already see what's going to happen when we get that half right. Minus, and then that minus here, I need to distribute it. That minus goes right here. I got to distribute minus, see? So I need to distribute that minus into both of these. So minus, let's see, minus tan integral secant cubed x dx. And then plus, that's what will turn into a plus. And then remember, look, I have the antiderivative right here. So plus, and remember, I have a 10 there in the front from this 10 that I got to distribute. So plus 10, and then ln, and what was my u? Secant x plus tan x. Secant x plus, that's a plus, tan x, close it, plus c. All right, so let me zoom in. All right, I'm going to send this guy over here. So you can put that 10, or you can put that 10 on the inside there. So now you're going to have two of those, just like before, right? 2 of the 10 secant cubed x dx equals, I got this guy, 10 secant x tan x plus 10 ln absolute value of secant x plus tan x plus c. And then just like before, multiply everything by half or divide by 2. And there's our hack. And yeah, I know, guys, I know. This one was ugly. Secant cubed x dx equals 5 secant x tan x plus 5 ln of secant x plus tan x. That's a plus c. I know, it wasn't the prettiest hack, but there it is. All right, guys, take care of this UH quiz. I know it was tough, but you guys can do it. You guys are sharp. All right, later, guys. Bye.